Let's talk about the story of Stephen Hawking, because it's truly one of the most incredible paradoxes you'll ever come across. I mean, think about it. Here's a man whose physical world was shrinking, eventually down to the size of a wheelchair. But at the same time, his mind was doing the exact opposite. It was exploding outwards, reaching to the very edges of space and time.
Okay, let's really unpack this, because this right here, this captures everything about his life. On one hand, you have his body, being progressively confined by ALS. And on the other, you have a mind that was just completely free. A mind that roamed the entire cosmos, traveling to the Big Bang itself, diving into the heart of black holes. It's like he lived in this double universe his whole life.
And that's really why his story hits so hard, isn't it? It goes so far beyond just a science biography. What we're really looking at is one of the most powerful stories out there about human resilience, about the raw, unstoppable power of just being curious.
So, to really get a handle on just how big of a deal Hawking was, we've got to step back in time. Let's look at the world of science he was about to walk into. We're talking the mid-20th century, and it was this amazing time of huge questions and some pretty intense debates about, well, the nature of reality itself.
And really, this was the big one. The question on everyone's mind in physics was, how did the universe even begin? What are the fundamental rules that run the whole show? And here's the problem. You had these two giant theories. On one side, Einstein's general relativity. That's the big stuff, right? The smooth, sweeping fabric of gravity, galaxies, all that. And on the other, you had quantum mechanics, the tiny, weird, chaotic world of particles. The real kicker? When you got to the most extreme places, like the moment the universe was born, these two theories they didn't agree. They gave completely different answers.
So what's sitting right in the middle of this huge scientific clash? This one little concept, the singularity. Just think about it. The theory was that the entire universe started as a singularity, and that the center of every black hole was also a singularity. And what is it? It's basically a point where our understanding of physics, all the rules we thought we knew, just breaks down. It all just stops working. It was the ultimate cosmic question mark. And right as Hawking is getting ready to take on this massive theoretical problem, this void at the very heart of the cosmos, he's suddenly forced to face an entirely different kind of void, an unimaginable one, right in his own life. I mean, look at this timeline. It's just staggering. Seriously, in 1963, he gets this absolutely devastating diagnosis. The doctors tell him he has maybe a couple of years to live. And then what happens? Just 2 years later, in 1965, he finishes his doctoral thesis on the inevitability of singularities. It's unbelievable. As his own body was being systematically shut down, his mind was firing on all cylinders, producing one of its most powerful works ever.
So here's the really crucial takeaway from this. His early work with Roger Penrose, this wasn't just some abstract academic thing. No way. What they did was prove that black holes and those singularities inside them weren't just some, weird theoretical possibility. They were an unavoidable consequence of gravity. Based on the laws of our universe, they had to exist.
But, proving black holes were a real thing, that was just the beginning for Hawking. He was on the verge of a discovery that would completely flip our understanding of them on its head. He was about to find a little glimmer of light, coming from a place of absolute total darkness.
See, before Hawking came along, everybody had a pretty simple picture of a black hole. It was like the universe's ultimate prison, right? Once something crossed that edge, the event horizon, that was it. It was gone, forever. Nothing could get out, not even a single photon of light. That was the rule, period. No exceptions.
And then Hawking came along and just broke the rule. It was brilliant. He blended quantum mechanics with relativity and came up with this incredible idea. Okay, let's walk through it because it's pretty wild. Right at the very edge of a black hole, these pairs of virtual particles are constantly popping in and out of existence. Now, sometimes one particle gets sucked in, but its partner manages to escape out into space. And that escaping particle, we see it as heat, as radiation. We now call it Hawking radiation. And the most mind-blowing part of all this, it means the black hole isn't permanent. It's slowly leaking mass and energy. And over immense, almost unimaginable timescales, it can actually evaporate and just disappear. But wait, this created a brand new, massive puzzle. What happens to all the information about the stuff that fell in? Does it just get erased from the universe forever?
You have to understand, this was absolutely monumental. For the very first time, someone had actually built a real mathematical bridge connecting the world of the very big
gravity, with the world of the very small, the quantum realm. By proving that black holes aren't actually truly black, Hawking did two things. First, he gave us our first solid clue in the hunt for a theory of everything, but he also threw down a massive new challenge, that whole information paradox we just mentioned. It completely pushed physics into brand new, uncharted territory.
So yeah, this work absolutely cemented his place among the all-time greats of physics, right up there with Newton and Einstein. But his story didn't stop there. His journey from this point on, well, it transformed him into something even bigger. He became a global icon, a symbol of human potential, and really, a voice for the cosmos.
And he never stopped tackling the biggest questions out there. I mean, take his no-boundary proposal. The idea here is that maybe the universe doesn't have a beginning in the way we think about it, no single starting point in time. Instead, he and James Hartle proposed that it might have just emerged from a state of pure quantum fuzziness, all governed by the laws of physics. No Big Bang singularity needed.
And the way he shared these incredible, breathtaking ideas with the world, it was just an act of pure, unbelievable will. For years and years, that famous computer voice of his was controlled by just a single muscle in his cheek. Can you even imagine the patience, the sheer determination it took to write entire books, complex scientific papers, and give lectures all around the world? Just like that? It's almost impossible to comprehend.
So when you look back, his legacy is just immense. Of course, he totally reshaped our understanding of physics, but it's so much more than that. He became this global symbol of intellectual courage, of what the human mind is capable of. Think about it. Through his book, A Brief History of Time, and just through who he was, he got millions of people who never would have thought about it otherwise, to just look up at the night sky and wonder. He made the universe feel accessible to all of us.
And all of this really leaves us with one final powerful thought. Stephen Hawking's life might just be the most profound proof we've ever had that the mind can truly transcend the body. He showed all of us that you can explore the entire cosmos from a wheelchair. So the real question, the one he kind of leaves behind for us, is what's next? What other boundaries, the ones that seem completely impossible right now, are we ready to conquer?